Hi, I'm Gale Banks, coming to you from Banks Power. Out in the shop, we've developed a new racing intake elbow for the 6.7 Cummins. It's our newest monster ram, and today we're going to have a flow bench shootout, pitting our monster ram against all the competitive intake elbows we could find. Here's the bottom line. Would you make boost at the turbo only to throw a few pounds away with a lousy intake elbow? You can lose some boost no matter what, but the best one on the flow bench has always produced the best power on the dyno. So let's go out to the flow bench and start this shootout. This is going to get real interesting. How'd we do?
Pretty good. We got 1,008 CFM and 77.01 pounds per minute.
So it likes the CNC job, it seems.
Yep.
All right, so I get to put up some new numbers. Okay, go ahead and pull that thing off. And 1,008 CFM. It's like, and 77.01. Go ahead and put that on the table if there's room. Pounds of air per minute. Okay. Thank you, Steve.
Yep.
So, what did we just accomplish here? Well, we're testing everything on the Superflow bench at 10 inches of water pressure drop through whatever we're testing. That's the equalizing thing, the pressure drop. How much will it flow with that boost loss, which is about 1/3 of a pound, 0.36 PSI is 10 inches of water. So I wanted to hit 1,008. We were at 968, and the difference is the inlet. We are machining the outside, which gives you a really great hose grip for higher boost levels, but I wanted to get the inside to align on our monster ram. This is for the 6.7 Cummins, like 07 to 17 year models. So what we did was we went ahead, and this will be in production, and we CNC'd the intake where the boost air comes in, and we picked up 40 CFM. So all in all, the old NACA technology that we're using from 1942 is still valid today. Back in World War II, the aircraft guys worked out, hey, we're ducting air around in these aircraft. Every time we make a bend, we have a lot of loss. Round tubes flow good in a straight line, and they flow terribly in a bend. That's just how nature works. If you shape the bend section differently, you can get a better, more uniform flow of pressure and velocity through the bend and way lower loss. That's what we've been doing in our high rams and our monster rams for the past few decades. In fact, it's one of my most copied products I've ever done. Everybody copies it. I think you're going to find that this old guy using this old technology, he can still kick some butt. Here's what we've done for this product. We started out wanting to fit the stock location where the throttle valve occurs in your truck. In other words, any boost tube that will go to this location, I wanted to accommodate. It's a 3.5 inch diameter. So to accommodate that diameter, we do a 3.5 inch version that puts that hose joint right where it was stock in space. And there's a few other things I wanted to do as well. One of them was not have to put a gouge or a shelf or something that really kills flow into the engine itself, into the cylinder head. but the stock fuel injection line on the number 1 cylinder flows right through where I wanted to put my bend. So what we did was I got with a major manufacturer of OEM diesel fuel injection lines, the same guys we use on our military diesel engines, and we made an injection line that clears where I want it to be. That's part of the package right there, and that is one of the keys, along with that NACA technology, to help you get the air around the bend and uniformly into the engine with minimum loss. So we're doing a 3.5-inch version. We're also doing a 4-inch version. Now the 4-inch version, as I pointed out, is CNC'd. And oh, by the way, so is the 3.5. So the 3.5 flows 906 CFM, or 69.22 pounds of air per minute. What's with the pounds of air per minute, you might ask? Well, that is what you mix with fuel to make power. Air-fuel ratio is fuel mass and air mass mixed together. If you look at this number, 77.01 pounds, and you run your engine at, say, 16:1 air-fuel ratio, which is kind of on the edge of smoke, and you're making about a brake-specific fuel consumption of 0.430 pounds per horsepower hour. That means it takes a little less than a half a pound of fuel to make 1 horsepower for 1 hour. You can calculate from that number what your power number should be using those two factors, 0.430 brake spec or a 430 brake spec, and 16:1. At 3,000 RPM, that number will make about 680 horsepower. So that gives you an idea of that airflow through this elbow. Of course, 680 horsepower isn't the limit. Our 6.7 Monster Ram is competitively priced, and it's designed to be the best intake elbow on the market at any horsepower and at any airflow, short of using our Big Hoss side draft racing intake manifold. What we've done also is try to accommodate every stock mounting position that's on the stock piece. And the stock piece has provision for dipstick tube. It has provision for a lot of emissions equipment, which these being racing equipment, they do not accommodate emissions equipment. These are for off-highway racing use only, or pulling, drag racing, whatever, road racing, whatever you think you want to do. The stock one, and this one is the 07 to 12 model, has a temperature sensor provision, has a pressure sensor provision, has a provision for mounting wire looms, and of course has a provision for mounting the dipstick, in addition to the emissions equipment. So ours accommodates all of that. Here's your wire loom, etc. Here's your dipstick mounting. This is the port for the earlier temp. And if you have a later model, a plug is provided to close that port. And here is your pressure sensor. I don't have a screw in that. Or on the later model, it's a T-map. It's temperature and manifold air pressure. These guys sticking out on the top are a couple of my straight shot water meth injection nozzles. And these have a 85-degree cone angle that they form inside the casting. We're spraying into a diffusing section. Diffusing means as I'm making the bend, I'm also increasing this cross section and slowing the air down so it's easier to turn, number one. And number two, giving you more volume to inject your water meth into. There's no wall wetting taking place in this design. In this design, we've targeted the nozzles so that they don't hit a darn thing. They go sweetly into the center of that air mass flowing through there. So there you have it. We've accommodated everything you need to accommodate. We've got good air pressure and distribution going into the intake manifold. We've designed a fuel injection line to give you the clearance necessary to do the job right. And we've got a pretty competitive price. We do a natural aluminum 3.5-inch model, fully CNC'd, for $339, internet price. If you want to paint it red, it's 24 bucks. It's hot paint, so it's very durable. The 4-inch in natural aluminum is $369. Same deal with the paint. And the line is 60 bucks. So there you have it, very competitive price. And we'll see how I do as we test the other competitors here from the marketplace.